Welcome back to another explainer. So today we're jumping right into a super interesting developer diary entry. It's from June 10th, 2026, written by a programmer named Ang, and it's titled Notes on Haskell-Programming Part 158. Now, I know what you might be thinking, Haskell, really? But stick with me here, because even if you don't write Haskell every single day, the core lesson we're going to unpack about writing bulletproof software, yeah, it's something literally every developer needs to hear.
Let me ask you a question right off the bat. Is your debugging logic secretly controlling your app? It's kind of a terrifying thought, right? But honestly, it happens all the time. It is just so incredibly easy to fall into the trap of using generic string manipulation. You know, just hacking strings together to get the text output you want, instead of relying on strict, robust, type-safe code to govern the actual logic. Well, today we're going to see exactly how Androids caught this exact vulnerability in their codebase, and, more importantly, how they fixed it. Okay, let's dive right into this. Section 1. The string manipulation trap. To really appreciate the fix Ang pulled off here, we first got to understand the pitfall they were dealing with. So the application had a specific export format, like a PDF or an EPUB. And to figure out the right file extension, the old code was basically just calling the show function on that format. It took the internal data type, converted it to a string, and then just mapped that string to lowercase letters. Meaning if the system sought capital PDF, it just spat out lowercase PDF. And hey, at first glance, that seems pretty clever, right? It's super concise. But there is a massive structural flaw hiding right under the surface. And that major flaw? It all comes down to what a show instance actually is. By definition in Haskell, a show instance is an internal function that's typically reserved for debugging output. Its entire purpose is just to help you, the programmer, see what's going on under the hood. It is absolutely not meant to drive your core file system logic. Relying on it is basically a hidden vulnerability, just waiting to blow up. Imagine a well-meaning developer comes along and tweaks the debugging label just to make it more readable in the console. Bam! Suddenly your file system paths are completely broken, and the worst part, the compiler wouldn't even warn you it happened. Which brings us to Section 2, building a type-safe function. So Ang immediately spotted the danger here and decided to pivot to a much more idiomatic design. Instead of hacking a debugging tool to do a production job, they built a brand new, dedicated function. Think about the type signature of this new approach. The extension function explicitly asks for an export format, and it guarantees a string output in return. It is a purpose-built tool designed exactly, and only, for file extensions. No more guessing, no more weird side effects, and definitely no more accidental breakages. And this brilliantly illustrates how that new function actually operates. We've got a clear, direct mapping now. The Haskell type PDF maps strictly to the lowercase string PDF without a leading dot. Type goes straight to type, EPUB to EPUB, TXT to TXT, and MD to MD. It is entirely explicit. The compiler knows exactly what to expect from every single format. We are finally done relying on the side effects of a debugging tool, and instead, we've got a concrete, undeniable contract for our file extensions.
Moving on to Section 3, decoupling debugging from logic. Now, if we zoom out to the broader software engineering principle at play here, this quote from Ang's diary absolutely nails the aha moment. They write, "It decouples the internal show instance from our file system logic." And that's exactly it. By separating your debugging features from your critical business logic, you are literally protecting the structural integrity of your software. You should never, ever have your core file operations piggybacking off functions that only exist to print nice messages to the terminal. It's just asking for trouble.
So what's the big takeaway here? Well, we now have a single source of truth for updates. Think about how much of a game changer this is for long-term maintainability. If, let's say next year, your team needs to add a totally new file format, or maybe alter an existing extension for some compliance reason, there is exactly one place in the entire codebase to make that modification. You aren't hunting through string parsing logic across 50 different files, crossing your fingers that you didn't miss a stray lowercase function somewhere. You just update your explicit mapping function once, and boom, you're totally done. All right, Section 4, cleaner code, fewer errors. Now, what's really interesting here is contrasting the final payoff. The messy old code strung together detached commands, mapping to lower, calling show, applying it all to the format. Honestly, it reads kind of like a riddle you have to solve in your head. But the new code, fetching the extension for the format and using it to replace extension in the path, I mean, it reads practically like plain English. You fetch the extension for the format and you replace it. It's incredibly clean and just immediately understandable. To quickly wrap up Ang's findings,
The benefits of this refactoring are just massive for the health of the project. First off, it completely moves the app away from that dangerous generic string manipulation. Second, it enforces a much more type-safe and idiomatic design that the compiler can actually help verify. Third, you're left with exactly one centralized place to modify file extensions going forward. Fourth, the correspondence between the data type and the output string is immediately clear to anyone reading the code for the very first time. And finally, putting all that together, it is just way less prone to errors. It's a total win.
Which leads us with a final, somewhat provocative thought to end on today. I really want you to think about the code you wrote yesterday or the code you're going to write tomorrow and ask yourself honestly, where else in your codebase is debugging logic secretly running the show? Where are you settling for string typing instead of truly robust type safety? Take Ang's diary entry to heart, go track down those hidden vulnerabilities in your own projects, and start decoupling your logic today. Thanks so much for joining me on this explainer. I hope it helps you write cleaner code, and I'll catch you in the next one.